Hi, this is your Sapil Bharti, and we are at KubeCon and CloudNetCon in London, and we have with us once again Greg Kroah-Hartman, Linux Foundation Fellow and maintainer of a stable branch, right?
Yes.
Or unstable branch?
Still the stable branch, yes.
Stable branch. First of all, Greg, it's great to see you again. We met last year, I think it was in Paris, if I'm not wrong.
Austria.
Last
Vienna.
year. Vienna, yeah.
I was in Paris after that. Different conference.
Different conferences, but everything gets blurry, right?
Yes, they all
The funny thing is that, you have been in Linux. I talk to a lot of folks who have been in the Linux community. They keep changing the company, but they keep doing the same thing, you know, and we have talked about that as well when you talk about the whole career graph. So I want to talk to you about what are you doing these days?
Still maintaining the Linux kernel stable branch. Sasha, Levin, and I do that work. We churn out a kernel every week for that, a bunch of different ones that people build their devices off of and rely on. Distros pull from, whatnot. So development process is going well. We do a new kernel release. Linus does a new one every 8 to 9 weeks. We've been doing that for 15 years. I had an interview with somebody like, how you guys do that? That seems like it's so hard, but if you just do time-based releases instead of feature-based releases, it turns out pretty easy. It works out much better. Everybody's on board with what's going to happen and they know what's going on. Kubernetes has a much longer time span, I noticed. I would think that it'd be nicer if they shortened it a little bit. It might be a little simpler, but that's us. Everybody works on different time scales.
Exactly. And you delivered a talk today as well, right?
I did, yes. I'm here at the CNCF Foundation Conference, KubeCon. I want to remind everybody that everybody uses Linux.
That's what I'm going to ask now. What are you doing in?
Well, it turns out everybody uses Linux, and I was I gave another interview a couple weeks ago with a podcast, and they're like, oh, we forgot that we all really do use Linux, but we don't understand what is Linux and what is it here for. And that's what all these containers, Kubernetes, all this stuff works on top of Linux, and they all rely on Linux. So I'm here to talk to that. Just mention, hey, we're down here below the thing. Linux Foundation still is a big part of your community as well. And also, we want your feedback because you are a workload to us. And we want to make sure that everything what you guys need works well for us, or that everything that you guys do and need works properly for Linux. So,
what kind of interaction is there between the Kubernetes communities, CNCF, and the Linux kernel communities? These are two disconnected but coupled communities. Or I just want to understand the intersection, the cross-pollination, or you're like, no, they're still distinct, we have to bring them together?
They're very distinct. I mean, they use the stuff that we provide, right? Some of the feedback, though, is good. Containers are not a native object in Linux. There's no such thing as a container from Linux at the kernel level. Kubernetes creates a container on top of that by piecing together a bunch of different Linux kernel things. Making sure that works well is good for them. They've talked, the networking especially, I know the networking team talks to the container people and working all these issues out. So there's a really good thing. eBPF, huge thing now it's in Kubernetes and monitoring your container and whatnot. eBPF community is the core kernel community. So those are good cross-pollinations and those are good, really good interactions. So yes, they're there. It's there. But like at the level I'm working on, mostly devices and new hardware coming up. Kubernetes doesn't care what kind of disk controller they're running on or what kind of network card they're running on. They just want to make sure their mouse works, right? It's just there. So at my level, know a lot. But then again, above that, the providers for Linux to run Kubernetes on top of care about a lot. AWS, Azure, Google Cloud, all those guys work very closely with the kernel community to make sure that they have a kernel that they can provide a solid base. They report bugs to us. We find out, they evaluate our CVEs and try and give a risk score to them for their use case. And that's great. And that's what the cloud and the Kubernetes people require. So it's not directly the Kubernetes developers always, but they're part of the ecosystem.
And now let's go back to the Linux kernel community. You folks have solved a lot of problems. Are there still things that keeps you awake at night, or you're like, nah, I just sleep like a baby? I think sleeping like a baby is bad, right? You're always hungry. Your diaper is always dirty, and you're always crying.
That's true. No, I mean, Linux is kind of unique in that it's a software project that is never going to be finished because there's always new hardware, right? There's always new stuff that the hardware manufacturers are creating, new different types of CPUs, different types of everything. So Linux we're not changing because we want to change, we're changing because we have to change, because people want to use this type of stuff. So yeah, our job is never going to be finished unless they stop making new hardware. So, but I mean, Linux is in everything. It's not just cloud. It's, Android, Chrome OS, the Wi-Fi chip or the 5G modems. are running Linux in the iPhone. So it's like Linux is everywhere in this type of stuff. There's a lot of different use cases out there.
Yeah, because case is different. Everything is abstracted. But you have to deal with the real hardware. A lot of innovation is happening in this space, and that innovation new devices keep coming up, new use cases coming up, which not only brings of course to support them, then security could become a challenge, size can become a challenge, scale can become a challenge. So, what kind of emergence of new devices that because in the very early days, I remember I used to talk, you will go and talk to Chinese vendors, they keep coming up new hardware and you convince them to. So what are the new breeds of devices that you are like, hey, these are the ones that are still posing challenge for even a mature community like the Linux community?
RISC-V. RISC-V is interesting. We've gotten some flack for saying don't make the same mistakes that ARM did. They seem to be making the same mistakes that ARM did. I mean, learn from history, guys. But they're doing well. I have a RISC-V laptop now, so it's nice to see that. They have some work to do on this stuff, but it's good to see. I also have now an ARM64 server, and the MIPS per watt number is really, really good now. So ARM64 is becoming a viable competitor in servers, which is nice to see. But so a lot of that is like, I'll call it RISC-V. Just learn from the prior. Don't fragment. Don't try and do your own thing. Work as your job is you want to sell chips, right? Make sure your chips sell well, run Linux well, and work with the community of that. There are some RISC-V vendors that understand this. Hence, I'm interacting with them and we're trying to get their code upstream and their drivers upstream. And it's getting better. But the architecture specific code in Linux is very small. So everybody uses the core of Linux very well. And then after that is the drivers for your specific hardware. So it's not really that big of a deal that way. The more complex beasts are the phones, the SoCs. Those are the most complex CPUs and system integrated out there. Servers are easy. Laptops are a little bit harder, but servers are hardware-wise. It's a network card, a storage card, and a bunch of memory, and maybe a GPU. It's actually very simple. Like a phone has like 350 different drivers for all the little tiny pieces all around it. It's so complex. So SoCs are still the complex beast out there, which is we're still doing a lot of work with that. But
when we look at AI-like workloads and people, quickly jump to Linux, to be able to run that, what kind of new use cases that you're seeing for Linux, which are less to do with the hardware specifically, but they do want to run on top of Linux?
Well, AI is just a GPU workload, just processing numbers. So Linux works really, really well. Gets out of the way, runs the applications as fast as it can, runs the network as fast as it can, runs the storage as fast as it can. So it's not really any different than a normal server workload for us. So we didn't really have to do anything special. New hardware, supporting new GPUs to do that, great. But a video card is more complex than a GPU in a way. So the GPU drivers are simpler in a way because they don't have to deal with a lot of frame buffer issues and a lot of other weird HDMI card devices and whatnot. So we don't really have, the whole AI world out there, besides the accelerator drivers, which we support, it really hasn't affected us much. We get out of the way and let them run their workloads.
Let's talk about security. And also, since we are here in Europe, last 2 years, CRA came and there was a lot of friction because while the idea behind was great, but there was some kind of disconnect between the community and the lawmakers. But then a lot of work was done, Linux Foundation, other projects, they try to work together. So talk about the security aspect. Is security, we can talk hard, all those, I don't want to go into that dark, gloomy to remind me where we were back then, but state of security today. And then also if we can touch on CRA and what do you think of CRA and what they are doing in Europe? And do you think that they should have something similar globally?
So security-wise, we are now responsible for all issuing the kernel for our CVEs. We are now what's called a CNA, a numbering authority. And that's good. So CVE.org allows open source projects to do this finally. And Python did it first, curl did it, Perl just did it. We've done it in the kernel, and a number of other smaller open source projects are doing that. And that's really, really good because it's up to the CRA is going to make open source projects be responsible for identifying or publicizing all the vulnerabilities that they have, which is fine. I want to take ownership of that and let the world know. Before we didn't publish anything. So now the kernel publishes all the CVEs. So we're averaging about 13 a day, security issues, which is actually less than the other operating systems. So this is kind of funny. It seems like a huge number, but a bug at our level of the stack as an issue of, oh, we can leak some memory, oh, we can crash the machine, or this more leak the memory. Most of them are tiny issues. There's a few occasional bigger ones, but we're identifying them all and we're pushing them out to the world. The trick is open source projects can't identify how their code is being used. So Linux is used in everything: cow milking machines, satellites, servers, Android. I don't know how it's being used, so I can't tell you if this bug is a severe security issue or a minor security issue. Same thing with tools like Python or Perl or curl. They don't know. And so the problem is trying to break down of how you identify the score of this vulnerability. Is it high? Is it medium? It's low? And the traditional method doesn't work for us because everybody has a different workload and everybody has a different issue. So the CVE board is realizing this, and we're going to try and come up with a way for us to not have to give a score and that way. And then different groups can justify the score on their own. I will call out Microsoft and Google and Amazon is working together and SUSE and Oracle to identify for the cloud use of Linux, these CVEs, here's the risk model. And here's the high, low, whatnot. And they break it down. They provide a whole bunch of meta information. They're not doing it for all 13 a day, but they're going through and they're doing this work. And I want to integrate that into our reporting as well. But they're doing a great work for this specific use case. Android takes a look at them all and says, okay, do these apply? Do they not? Do we even build this code in? So a lot of its stuff is the majority of all these CVs, they're not even building the code because you're only using a small portion of our 40 million lines of code. So it's those types of individual use cases that are important. The CRA, is the EU law, did get worked out. So they do understand that the open source communities don't have the same rules or risks that a company does. But the CRA puts a burden of proof on the companies that integrate the open source into their product. So it's like you ship a product, you have to get a CE mark for the electronics in there. It's not the manufacturer of that chip, it's the manufacturer of the device itself that's responsible for that. And that's what it is. They're going to dictate software bill of materials so that you will know what software is in it. They will have to update based on vulnerabilities that are known for that software. They will have to report vulnerabilities that are found and reported to them. And this is a good thing. I think it's a really good thing. So the law is finished. Now comes the specification part. So they said, you must do this type of thing. And now we need to get down into the details. Like, what is the risk model here? What is that? And me through the Linux Foundation Europe, I'll call out Eclipse, Apache are also doing this work with the EU group. We're a part of the expert group. We're going through and defining what is the different categories, what is the risk categories, and the specifications for actually how to break down this and do this stuff. There will be some new rules on, I don't know if they're going to use a CVE. We might have to report to CVE for the US and China and whatever the CRA sets up in Europe. We'll have to report to a different one for Japan, maybe a different one for India, which is fine. I want to be agnostic. I can push these to anybody. Any open source tool can do the same. Oh, Kubernetes, they're also a CRA. And so they also do in charge of their own stuff. I've talked a lot with the security people from Kubernetes. They push out a very smaller volume, so they can still do it easy. So the CRA is good. And I think over the next year and a half, I think we'll be finalizing the specification. It's a public process through ETSI in the EU, and it'll come out as specification. I think it needs to be finished 1.5 years from now, and then it'll have another year before it goes into like full effect. I think it'll be voluntary in 1.5 years. It's going fast, it seems like, but it's good. And this is something that actually the US government also requires, the same rules almost. So it would be nice. I did see some reporting saying maybe that the UL labs in the US are going to do much the same thing for devices in the US, because software is in all these devices and you want to have it be able to be updatable and fixable and things like that. And vendors who ship devices with software need to be responsible for that. They can work with the open source communities and us. We're here glad to work with them, but the responsibility is on them for when they bundle it all together and ship it to a consumer. And that's good. That's the same thing as dealing with the metal in it or the electronics in it or the paint in the device. Same rules. Software should be no different.
We have asked this question, and because since I met your son also this morning, so once again, I will talk about what are you folks doing to attract the new generation. First of all, they're all TikTok audience. They're all, Reels. They watch the Reels. Talk about how are you building the future generation because kernel is the foundational technology. This is not a technology. This, no offense, is not like, I cover mainframe also. Mainframe is also critical in today's modern world, but this is not a technology which, it's an ancient technology. No, this is the foundational technology of modern economy. What are you folks doing to attract modern maintainers, developers to the kernel?
we haven't stopped. We have over 200, maybe 250 new developers every 8 to 9 weeks join our project. Submit maybe just one patch, drive by, but no. We had 450 people apply for the kernel mentorship intern program last round. We have a huge number of people applying for this stuff. The university where my son goes to, they teach the foundation of systems development and a little bit of kernel stuff, and they know that kind of stuff. This is out there, and people are doing. We have more developers on our project than any other open source project. Almost 5,000 developers last year, 350 companies. We're not exactly a shrinking project by any means, but we still have a huge number of new people coming in. It isn't. If you look at our numbers, we're not shrinking. That being said, we can always use more. Sue is doing a great job with the mentorship program, with the intern program. The main limit of what we have is the number of people that can be a mentor. So we don't have a lack of the people wanting to be part of the process. We have a lack of people being allowed by their company to participate as a mentor of it. So I would want to see more companies allow their kernel developers to be a mentor to other people, because everybody who comes out of this process, they either usually, I'm going to go back to my university, or they get a job. And this is all these companies are hiring these people and they kind of disappear, which is great. That's fine, but they have kernel knowledge and these companies need people with that. So we have they're asking for more developers, so they should allow their maintainers that work for them to be part of the process, and they get hired. So this is good. They get hired from them.
So you have a scalable problem because talent is there, but you don't have enough maintainer to just.
It's a maintainer problem. Yeah, the opposite problem.
But have you also seen that? I don't want to get into that specific, but specific regions where you see there are more people, because different regions they have different education system, where you're seeing that different regions, that's where most of the developers and maintainers coming from.
It's all around the world. I call out, it comes down to the university you go to. It's like some universities are more theory or knowledge, or like higher level, like F#, or some knowledge or system, some university system. And that just in the same country, you can have different universities do different things. So it depends on the university system. So I can't call out any one. Europe has a huge one, India has a huge one, US has huge, in some different universities. Some universities no. So again, it comes down to the university system that's churning out these students. It's all over the world. So I don't see we don't see any one area that no, or any one area is yes. So.
I've been covering open source from the very early day, and we are at the conference where everybody uses, but it feels that people have forgotten that they are using open source. And then they also forget to be a good open source citizen. But I know because you're a very, very positive guy. So you also will always be positive. But in the journal, are you saying that we should talk more about open source, or you feel that people are doing enough open source, we don't have to go out and educate them about open source?
I think we always need to educate about open source, right? The way everybody succeeds is by contributing to this. You're relying on these facilities. Everybody contributes to open source in a selfish manner, which is fine. Contribute to solve your problem, because it turns out everybody has the same problems. And open source is a commodity, right? Everybody's not making money on this level of stuff. They're making level on the value add above that. And that's fine. This is the building blocks that we provide for you to solve your problem, your business problem, whatever it might be. So these are the underlying pieces and parts that you rely on, so contribute to it. And then also, when you do, it saves you time and money. You're not having to try and work around things. If you hire 1 or 2 developers for the project you're relying on, you get a much better product overall for you. And it saves you money to do this stuff. It's cheaper. Intel and IBM proved it long, long time ago. It saves you time and money to work with the community than to ever do that. So there's a business case to do this. So it's not just that. So yes, I would always want people to work, talk more about open source. They don't realize it, and that's kind of good. But in the flip side, we do need to emphasize all this is open source. Contribute to it, because you are relying on it.
And you have no idea how many times I've quoted you that saying, that we need selfish users, because the charity, people forget about it. Your charity, you donated, you're done. But if you're a selfish user, your success is tied to the success of the project.
Yes.
So you will. That's why I know that quote. I have used so many times that Greg always says this: we need selfish users, because that makes the project sustainable.
Yeah.
Because your success.
And you're relying on it more, and you want it to succeed, and using open source has let so many more things grow than ever before. You can spin up the whole old LAMP stack, right, with the whole first.com boom, and now all the Kubernetes and all the cloud native stuff. That's all thanks to an open source thing. If we didn't have open source, you wouldn't even be able to do this type of stuff.
And your talk was also, you said you talk about Rust this morning? No,
I talked about Rust.
Yeah. So, when I talked to Linus also, I brought up the point of Rust, so I will ask you also, just, what is the kernel community thinking of?
So I talked about this today, Rust, and I was a skeptic a year or two ago. I have a friend many years ago who said, "Oh, you should try Rust. It makes programming fun again." I was like, "Ah, okay," and then I ignored him, and he was right. I should have listened more to him. Rust is nice in that from a C programmer's point of view, you can kind of do the same thing. It looks the same, but the compiler makes you actually think about what you're doing more. You can have to, and once you get it right, it's always right. The memory accesses are there, the proper ownership of stuff. Oh yes, I really did have to check my error conditions. You kind of get frustrated a little bit, but then you realize that once this compiles, then I just can focus on the logic. And the logic is what, as a programmer, you care about. You don't care about the syntax and some of the other foolish things. The cool thing about the kernel, since I've seen every single security bug for the past 18 years of the kernel, the huge majority, I say 50%, somebody quoted me and said, no, I'm undercounting it, would be solved with Rust. Because there's stupid things like, oh, I forgot to unlock this lock. Oh, I forgot to grab this lock. Oh, I had a memory leak because I forgot to check the error condition. The Rust compiler won't let you do that. So going forward, I think it's a proper way forward to make it easier for both main developers to write code, and I'd call out maintainers. It's going to make our job easier. If this stuff compiles, I know it will work because it passed the compiler. I don't have to look and think, oh, is this lock held? Oh, did they clean up properly on this error path? Because it's just there, and we know that's there. So then we can focus on the logic problems. As a maintainer, it would make my life easier. Now, the tricky part of Linux is we have 35 million lines of C code. The intersection between C and Rust is very tough. It's kind of the hairiest, craziest stuff that Rust can provide. So as a maintainer, jumping in, seeing these bindings between C and Rust is a very tough thing. And now I can say I can read a binding. I can never write a binding, but I can write Rust code on the other side of it. We have some very, very talented Rust developers who are doing this work. We don't want to, again, they're contributing in a selfish way. They want to solve their problem. Developer at Red Hat, Danielle, he wants to write the new NVIDIA driver in Rust. So the Apple developers working on the Apple chip, they wrote their new DRM driver in Rust, and they were able to say, this is much simpler for us. So they're contributing to Linux and Android. They rewrote Binder in Rust. So they're contributing all this code to Linux in order to solve their problem in a selfish way. And let's take advantage of their contributions. I think it's way forward. It's going to make drivers much simpler to use and better. So we don't rewrite the old code. That's fine. Google's proved that if you just do the new code in a language like Rust, it's a better thing. I do want to call out, people get confused about memory safety. They say, oh, we can't do memory errors in Rust. You can do tons of memory errors in Rust. Rust isn't going to save that from you. You can scribble all over memory. I showed an example today where I can instantly crash the system in Rust with a off by one error. Now the thing is, Rust, a lot of the ways when it crashes, will just panic the box, reboot the machine, and away you go. In C, you would start scribbling over memory and you could get a vulnerability. Like you could take over the box. You could do other things. So Rust isn't going to be safer you'll still get a CVE because you can reboot the box, denial of service, but you're not going to have a vulnerability in taking over the machine. There are ways you probably can do it as well, but it's not going to save us from those basic issues of scribbling over memory in the wrong way like that. But it will save us from the issues of this memory object is properly controlled and the lifespan is known. Maintainers have a hard time with Rust because we now have to define our C interfaces in a way that Rust can understand it. With the driver model, the Rust developers came and said, here's this code, we're going to bind to this stuff. I'm like, this is crazy. And they're like, no, it's right. And I went and talked to them and they were a little bit wrong and I was a lot wrong. So again, it comes down to people and interacting and figuring out this stuff. I sat down with them and worked through it all. One thing famously, they're like, we're doing 1,000 lines of this Rust code. I'm like, why? It's 2 lines of C code. They're like, well, we didn't want to change the C code. I'm like, well, I can make it 3 lines of C code to make it your easy. Oh yeah, okay. Part of it's just interacting. I did it in C that way because I could do it in C that way. Let's both work together. And we've changed a lot of C code in the kernel already to make things safer for the C side, because we've defined our interfaces better. If Rust goes away, we've already fixed a lot of bugs if it added. And that makes the Rust code easier. So it makes maintainers do more work at the beginning. And we're all overtaxed as it is. It's overworked. But going forward in the long run, I think things like Rust can help us write drivers that are safer overall and easier to write and easier to maintain. Because we write code for people first, compilers second. And that's important. We have to maintain this stuff for a long period of time. That's a totally different engineering model than writing a one-off code.
Greg, once again, thank you so much, for, taking time out and, talking to you reminds us of our own roots or the foundation, because that's where I come from, sir. So thanks for taking time out and talking to me. And it's always a pleasure.
I'll see you in the next city.
Yeah, awesome. Perfect.
All right, great.
Thank you, sir.
Thank you.